In this video I'm going to be showing you how to make a grass scatter in Blender 4.3. It's going to be fairly advanced. We're going to be taking use of the new for each loop to make our own grass instances within geometry nodes. So this whole thing is just one geometry nodes object. There's not even a separate grass mesh or anything that I've made for this. So yeah, it's all hyper procedural and customizable. So yeah, let's take a look at the geometry nodes system and I'll go through how we can make this from scratch. So there's a few things going on. We have our base mesh, and then we have some color attributes going on with this, and we also have our scatter section, which is just scattering a dense amount of points, and we're instancing the grass onto it. And this is where the interesting part comes in, because we're going to be using the for each node to automatically generate variations of grass and use those as our instances to scatter on this. And yeah, this gives us quite a lot of like range in the assets we're scattering. So you can see this is just with one variation, and we could take that up to 10. We get a lot more sort of natural randomness that you can't really get from just scaling and rotating. So in a blank file here, I will delete out the light and camera, and I'll keep the default cube as my object to put my node group on. So over in geometry nodes, I'm just going to reorganize these windows a little bit. I like to have it a bit more like this. And let's just collapse that down now so we can see our node tree. Let's get rid of the input geometry, we don't need it. We can start with this grass ribbon, and the way I'm going to start with it is by using an arc node. And what this essentially allows us to do is just make like a segment of a circle basically, and we can control that with this angle. And you can see, like, if we set it to something like this, it basically gives us a nice little base for a grass ribbon. But I want to change the this arc node to points rather than angle, because I want to be able to control the bending a little bit more than what we're currently able to. So I'll just zero everything out for now, and then I'll set the endpoint to be 1 up in the Z direction. And if I set the midpoint to be 0 on the Y. Now what I can do is just, well, first of all, let's move the Y end direction to maybe 0.3 or 4 or something. And then I'll move the midpoint on the Y to control the bending that we get. And on the Z a little bit as well to get a nice natural shape. And yeah, this can be our sort of bend parameter maybe, or maybe, yeah, this end point can be actually. So I'm going to use a combine XYZ node, and I'm going to plug that into the end and put our values back in that we had, and go ahead and drop in a value node out of the Y there, and we can call this like bend. And that should be fine for now. So what we want to now do is just curve to mesh this and make it into a ribbon shape. So let's go ahead and grab a curve to mesh node. And let's drop in a curve line and drop that in there. And let's go ahead and set that from Z to X. Let's set it to 0.1 on the X and minus 0.1 on the start X. And then I'll add in a transform node and just plug a value into the scale. I'll set it to 1 by default, and this will just drive our thickness. So I can actually make that an input, call this width. Just setting F2 to rename these value nodes, it's quite useful. And now I want to control the radius along the length of this curve, so it's not always the same. So let me go ahead and set the radius, and I'll set it to use the spline parameter, and I'll remap it through a color ramp like so. And if I bring the 0 value up to a value of maybe 0.3 and this white down to something quite narrow, maybe like 0.05 or something, and then in the middle I'll just pull up this value to be much brighter. Set this to maybe B-spline will work nice for this actually. And now I just want to push these like middle loops in basically. So first of all, I'm going to resample this curve that we plug into our profile curve. If I go into wireframe mode, you can see why. I basically just want 3 loops across this whole thing. So what, 2 on the edges and 1 in the middle. So I'll set this to 3, and then use a set position after all this. And I will grab the end point. Sorry, I'll put the set position after this resample, And I'll grab the endpoint selection node, plug that into the selection, and now you can see I can control these like these other points here. I'll just pull them out a little bit on the Y so we get that kind of shape. And honestly, that should be fine for our grass ribbon. So I'm going to go ahead and group this now, which is something I don't typically do, but because we're going to be using the for each node, I wanted to do it like this so it's a little bit simpler when we come to put this in a loop. So yeah, let's expand this out a little bit and call this grass blade single. And I'll just name our parameters a little bit here. So I'll set this to float again instead of a vector. And I'll just call this width. And I'll call the Y bend amount. So now I basically want to instance this a bunch of times on some points. But the typical way we would do this is, well, I'll just get some points first. So if I make like a mesh circle, I'll make a curved circle. And let's do curve to points. So now I have my points, I have my instance. The typical way I would do this is with an instance on points node. However, doing it like that won't give me much control over being able to randomize each individual grass blade on the instance on points. I'll only be able to scale and rotate them. I won't be able to say change this bend amount, not in a dynamic way. So instead, I'm going to use the new for each element for loop here that we have. And I'll plug in my input here, and I'll take this second generated output. This is going to be based on whatever we do inside the loop. And this first output's just going to be sort of pass-through output. So if I just plug the element into the geometry, you can see we just get all the points here. And I don't want to plug my mesh of the grass blade into the loop. I want to plug these points into the loop. And now this will essentially allow me to do some operation on each one of these points. So what I want to do is first of all just set some grass blades to be joined at every point. And now we have a bunch of grass blades. They're all just stacked on top of each other because they're all set to the default position. So to set them to the positions of these points that we've just generated, I'm going to grab a position attribute. And you can't use fields inside the for loop because this is on an individual geometry element, so it has to be just a single number. So I'll drag the position into the input of the group. And I'll drop in a transform geometry and plug this input position here that we got in the group into the translation. You can see now we get grass blades on all of our curve points. So I'm going to decrease the radius a lot. And I want to get the rotation in as well. So I'll drag that in as an input, plug that in, and you can see now we get the rotation for each point. And notice how these lines have gone from dash to solid. That means that we're now no longer working with a field or working with a single value, which is why we can use a transform geometry. And now I'm going to drop in a rotate rotation, and I'll set this to local and play with these values a little bit. Maybe 90 degrees on the Y seems to work, and 90 on the X. Now you see we get a nice little thing here. I want to randomize these point positions a little bit as well, so I'll go ahead and do that before we plug it into the loop. Just use a set position, and I'll grab a random value, set it to vector, and then put it to -1 on the minimum on the X and Y, max 1 on the X and Y, and 0 on the Z. And plug that into the offset, and you can see they move around a lot. I'll just use a vector math set to scale to decrease that effect, but we still have a little bit of it occurring. Alright, so now back in this loop, I want to do something that we previously couldn't do with just instancing on points. I want to drive these bend and width values actually based on the distance from the center here. So I can do that now using this input position. So if I take the length of this position, that will basically give me like a spherical mask from the center outwards. So as a point gets further, this value will increase. If I just plug that straight into the, say, the width here, you can see that we are getting like some thinner stuff at the beginning, and it gets thicker as we go out. And the range of this is just a little bit messed up, so I need to map that to be something more visible. Something like that, maybe. And I'll plug this straight into the bend, not the width. And now you can see they are straighter in the middle and they bend more as they go outwards. So we can go ahead and just do something like that, perhaps. Maybe a little bit less. You can always add these as parameters. And I want to randomize the height of these blades a little bit as well. So I'll go ahead. I could add an input to this grass blade, but I'm just going to transform them based on a random value. I'll just combine a random value into the Z component, plug that into the scale, and now you see we get an invalid link because to use a random value inside this loop you need to plug the index into the ID so that this random value is not a field on every point, it's just a single value. So let's see, let's change the seed actually, and let's set the X and Y scale to be 1. And we get a bit of random height. 0 is obviously too low, so 0.6 maybe. And we could always increase like the number of points we have on these, or anything we want really. And something like that could be pretty cool. So yeah, this is essentially our grass clump. I'll get rid of these 2 value nodes now. And oh yeah, I could randomize the width as well with like another random value with the index into the ID again, and maybe do that. We get random width now, which we couldn't do before, but yeah, maybe I'll do that. The more randomness, the better, really. So I can go ahead and take this whole setup now and just go ahead and group this. And I can call this our grass clump. And as an input to this, I want to input a seed value so I can randomize this. So every time I use a random value, I'll just drag this input node around and plug the seed in, just so I get like a lot of control over the distribution and everything of this. Something like that. So you can see as I just play with this seed, we get completely different results now. I now have this grass clump. I want to do the same thing. I just want to make a bunch of variations of this thing. So I'm just going to drop down some points. This point count will be the number of variations we produce. So I'll set it to something like 10. And I'll grab another for each loop. Plug in our points. View the second output. And now if I just plug the geometry into here, we have this 10 times stacked on top of each other, because that's how many points we have. So for now, what I want to do is just transform this, and I'll transform it by the index on the z-axis. Just so we can visualize it, I'll remove this at the end. And you can see now we have all our variations lined up. Turn off this wireframe. And they're all the same right now, but we can very easily randomize that just by plugging in. We could either plug in this index. We need to plug in this index to the seed basically. So I'll run this through. You could run it into a random value ID again, or you could use the new node in 4.3 hash value and just plug this into the value and do it like that. Make sure you disconnect the grass clump from the output, so it's only going into the output of the loop here. And let's plug this into the output actually. And you can see we get some like random results. We could randomize this like a bit more maybe with like a random scale. So let's use a random value vector for that. Plug the index into the ID, plug that into the scale. Set our minimums to 1 for now, and maybe just make some there a bit shorter, some there a bit taller, and yeah, do that kind of thing really. And you can see we get like some naturally different grass clumps forming out of this. And we could also like even input the count as like a parameter here to give it more randomness. So we could just use another random value set to integer. And let's put 19, let's put 25 as our max and 15 as our minimum. Index into the ID, that into the count. Now we get random amounts per variation that we're making here. So we've essentially just made a bunch of variations of this grass clump. We're now ready to instance them, essentially. So before we output them from this for each element, they're all, see, as you can see, they're all vertices at the minute. I want to convert them into instances. So I'll do that inside the loop. And now you can see we get a bunch of instances. We have 10 instances, 10 variations. And you'll notice in the spreadsheet we now have these new like name attributes that we have. So we can go ahead and set name before we do any of this. Just call it like grass variation. So now I'll get rid of this translate component so they're all stacked on top of each other. And that's perfect for the instance on points node. And these will be our instances if we pick instance. And now we just need a mesh to scatter on. And you could just, you know, take the group input here, which would be our cube, I think. Yeah. And distribute some points on it and stuff like that. Or you could just make something procedurally. I think I'm going to go ahead and make something procedurally. I'll just take a grid and distribute points on faces and plug our points into here. And if I make this grid like 10 meters, give it like 50 vertices and displace it a little bit using just a set position and a noise texture set to color. Actually, let's do this a bit differently. I like to do the normal scaled by this noise texture, so we get more of like a vertical offset. Let's set the scale down, maybe 0.1, 0.2, something like that. And scale it again to turn the strength up a little bit. Untick normalize. Just trying to make some interesting looking terrain. And we can go ahead and set shade smooth on this, like so. And distribute our points we want, probably more than this. I'd say about 1,000 or 100 maybe. Instance on the points, and we have all our grass instances being randomly picked. If I turn this density down, you'll be able to see that a bit more clear. They're actually picking random versions of this, but in order to just fix how this looks, I'm going to plug the rotation into here. And to give random rotation, I'll add a rotate rotation node, set it to local, add in a random vector value, and turn off the X and Y and just turn it around on the Z a bit till they look quite random. And in terms of scale, I'll add in another random value as well. Plug that in, make sure it's a float, and set the minimum to like 0.4 or something. And what I like to do is multiply this by noise texture so we get some overall variation. You don't have to, but I like to do it. So I'll go ahead and drop in a multiply, grab a noise texture node, plug that into the factor, and I will go ahead and drop a color ramp here, untick normalize, turn the roughness down on this, set the scale to something lower. You can see we're getting some nice like patches occurring, probably still too high in scale though, so turn this down a bit more and increase the black value so it doesn't go to 0. Maybe something like 0.4 works nicely. Now we get like longer clumps. Now all that's really left to do is rejoin our original plane. So drop in a join geometry, plug that back in so we have that at the bottom like so. And let's go ahead and give this a material and a color. I will open up a shading window in addition to this geometry nodes window, and I'll just call this grass. Set that in here, and if we go into material preview mode, I just want to give this a nice variation of color, and I want to do it using a noise texture, but I won't be able to do it in the shader editor directly because it will try and do it on each sort of individual grass instance, which isn't what I want. I want like a texture that's based on the ground. So I'm going to create a noise texture in geometry nodes first. So I'm going to store a named attribute, call it text, and grab a noise texture. And let's go ahead and store that there. And let's store this on as a float on instances. And then let's grab an attribute node, set it to instancer, grab our texture, and now we can read that in. If I decrease the scale in here, we get like a nice global noise effect. Turn the roughness down probably, maybe not all the way down. And let's run this through a color ramp, plug it into the base color, and just pick some nice like grass colors. And we can like pull this around a little bit and play with the noise. But yeah, that's pretty much it. We can increase the roughness a little bit maybe. If you're rendering this in cycles, I might like go ahead and add a translucent node and mix between these two. That can look quite cool, like this. And if I go ahead and render this in cycles for a moment, I just turn off scene world for a minute. That can like add quite a lot to your like shader here because it softens it up quite a bit. So that can be a nice little trick. But yeah, that's pretty much it. You can go ahead and like add a bunch of inputs to this system to fully, get maximum control out of this. You could spend more time making the grass asset a little bit nicer. You could also make like different assets that you could scatter on top of this, like some flowers or something that are all just slightly different to each other. So yeah, like the difference is just it's fairly subtle in like the node tree, but then when you actually see it all come together, I think it makes a big difference being able to like generate all these variations. And you could generate like way more than this and still be fine performance wise, really. So yeah, I hope this was useful to you, and I hope it gave you some sort of like practical example of the how we might use these new nodes in Blender 4.3. So thanks for watching, and make sure to subscribe for more.